Hey folks, a quick math hint when you are calculating the work done by or on a spring. So quick refresher here. You got force versus distance. It's the line. The equation for the spring, the magnitude of the force in the spring is force equals kx. K is the spring constant. And we talked about already that work is equal to 1/2 kx squared. You gotta be careful though about calculating that, and let me explain what I mean. Let me give you some numbers. Let's say that, and you're welcome to write this down or not, but just make sure you're paying attention. Let's say K is 100. I should make it 1,000 newtons per meter, and let's say that the spring is already stretched. We'll call that 4 centimeters. And I want to stretch it to here, which is 6 centimeters, okay? So the area that you're going to find is the area of that trapezoid. Now, you could calculate like this height, and you could then split this trapezoid up. You could either do trapezoid formula for area, or you can split this up and do a rectangle and a triangle and find the area that way. So you can certainly do all that. But you can also use this equation up here to calculate the work, which might be a lot quicker, but you gotta be careful, okay? So you have a starting x and a final x. So the work in this case would be 1/2 k x final squared minus 1/2 k x naught squared. Okay, so no problem there. Now you got to be careful with your math, okay? Okay, okay, there we go. Sorry about that. I had a little technical difficulty. So for the math, what do you need to make sure you do your order of operations correctly. So what do you do first? Do you subtract or do you square first? Well, you square first. So in our example here, the correct way to do this would be to say 1/2 times 1,000 x final in meters is 0.06 and then squared minus 1/2 times 1,000 and then x naught is 0.04 meters squared. If you did this, you would get, I'm going to calculate this real quick. This would be 1.8 minus, let's see. I'm doing the calculation right now, minus 0.8. This would be exactly 1 joule. So your answer here would be 1, okay? That would be the area of this whole thing, okay? Now, a quick can you or can't you? Could I do this? Could I do work? Could I factor out, because there's a 1/2 k there and a 1/2 k there. So could I do 1/2 k times x final squared minus x naught squared? Absolutely. Try it out. If you take 0.06 squared minus 0.04 squared, and then take that times 1/2 of 1,000, you're going to get that answer. Okay, no worries. Can I do this? Can I do 1/2 k x final minus x naught squared? Okay. The answer is no. Okay. So if you try this, 0.06 minus 0.04 is 0.02. If you square that and then take that times 1/2 of 1,000, you get 0.2 joules. That is not right. Okay, the answer is 1. Okay, so just make sure that you square before you subtract if you're given a starting and a final value for the x, for the stretch of a spring. Okay, so you can either do this would always work, or you are welcome to factor out the 1/2 k before, and then square your two x's, subtract those values, and then take it times 1/2 k. All right, I hope that was helpful, and thank you very much.